Next problem is the transition from state n equal to 4 to n equal to 3 in a hydrogen-like atom results in ultraviolet radiation. Infrared radiation will be obtained in the transition from. Okay, now we know that if there is a transition, okay, this is 1, 2, 3, 4 and 5. Then if there is a transition from any orbit to another orbit which is having lower principal quantum number, then energy is released, and that energy delta E is given by some constant, okay, upon 1 upon n1 square minus 1 upon n2 square. Now we know that if we find out the ratio of energies keeping only this term in mind, then in the case of 2:1 we will get some constant k 1 by 1 minus 1 by 4, that is 3 by 4. This will be k times 1 by 4 minus 1 by 9, okay, which is equal to 5k by 36. So in A, B and C, the energy that is released is more than the energy which is released in this case, 4 to 3. Okay, now only in the case of 5 to 4 the energy released is much less, and we know that the radiation, ultraviolet radiation, has more energy in comparison to infrared radiation. So we need that kind of transfer of electron from higher state to lower state where the energy released is lesser than this, and only in the case of D we have energy release which is lesser than 4 to 3 transition. Okay, so option D is the correct one. Now the next problem is 1 kg of a diatomic gas is at a pressure of this much. The density of gas is 4 kg per meter cube. What is the energy of the gas due to its thermal motion? Now we know that the energy of the gas is given by nRT half nRT times F, okay, where F is the degrees of freedom. Now in case of a diatomic gas, degrees of freedom is 5, so it is 5 by 2 nRT. Now this nRT can be written as PV, assuming gas to be idle, so 5 by 2 PV. Okay, now we are given pressure, we have to find out the volume. Now volume is given by mass upon density. Now mass is 1 kg and density is 4, so we have 1 by 4 meter cube as the volume. Now we have to find out the energy, thermal energy of the gas, which will be 5 by 2 times PV, that is 5 by 2 into P is how much? 8 into 10 to the power 4, and V is 1 by 4. Okay, so this will cancel out and we will have 5 into 10 to the power 4 joules as the thermal energy of the gas. So option B is correct.